Conic section ellipse is a set of all points in a plane whose sum of distances from two fixed points is equal. Those two fixed points are called foci, f1, f2. So sum of distances to any point on the ellipse from these 2 points is going to be a constant. So distance between f1q plus distance between f2q is going to be equal to distance between f1p plus distance between f2p. And that's true for any point p and q on the ellipse. So that distance is going to be a constant. Major axis is the line containing the foci, the longer axis. Vertices of the ellipse are the endpoints of major axis. Minor axis is the shorter line or the line perpendicular to the major axis that passes through the center. Co-vertices are the endpoints of minor axis. So if an ellipse is centered at origin, equation will look like x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. Right hand side must equal to 1. Always keep in mind if x squared has a bigger number in the denominator, x-axis will be the major axis. If y squared has a bigger number in the denominator, y-axis will be the major axis. So vertices will be along the major axis, co-vertices will be along the minor axis, and foci will also be along the major axis. To find the coordinates of foci, if x-axis is the major axis, will be plus minus c comma 0. If y-axis is the major axis, it would be 0 comma plus minus c. They'll be along the major axis. To find the coordinates of foci, we can use the relationship c squared equals a squared minus b squared. We could have our ellipse shifted where center is not the origin. Center can be h and k, and we can just shift center and vertices and co-vertices just like we translated the graphs. Let's see some examples. The first one, x squared over 25 plus y squared over 9 equals 1. So x squared has a bigger number. That means the major axis is x-axis. And along the x-axis, if I write it in the form of a square, y squared over b squared equals 1, along the x-axis, I'm going to move 1, 2, 3, 4, 5 on the right-hand side, 5 on the left-hand side. And for the minor axis, I'll be moving 3 up and 3 down. We can connect these dots, and that would be our vertices along the major axis. So that would be 5, 0, negative 5, 0. Co-vertices would be 0, 3, and 0, negative 3. Next, we want to get the foci. To find the foci, we need to use a relationship c squared equals a squared minus b squared, or the bigger number minus smaller number, which is 16. C squared equals 25 minus 9, which is 16. C comes out to be plus minus 4. So my foci will be 4, 0, and negative 4, 0. Foci will be 4, 0, and negative 4, 0. That's all about graph of this ellipse. Let's see another example. Graphing x squared plus 9 plus y squared over 16 equal to 1. We want to make sure that we recognize the bigger number is under y here. So that would be our major axis. In the y direction, I'm going to be going 4 up, 4 below. So 0, 4, 0, negative 4 are my vertices. And to find the co-vertices, we're going to be going 3 to the right, 3 to the left from the center. And let's go ahead and connect these points, and that's going to give us our ellipse. To find foci, we need to use c squared equals a squared minus b squared. A squared is a bigger number, keep in mind. 16 minus 9 is c squared. C is equal to plus minus square root of 7. So in that direction, I'm going to be moving 7, square root of 7, which is little between 2 and 3. So that would be coordinates of foci. So that's F1, F2. I'm going to write the coordinates here. F1 will be 0, root 7. F2 will be 0, negative root 7, because they're along the y-axis. And the center was 0, 0 in this case. Another example. Here my ellipse is not given in the nice shape and form that I'm used to seeing, so I must have a 1 on the right hand side. We're going to divide everything on both sides with a 36 first. So divide with 36, divide with 36 to get a 1 on the right hand side. So I'm left with x squared over 9 plus y squared over 4 equal to 1. And that's the ellipse I'm going to be graphing. We can clearly see the bigger number is under x squared. So x-axis is our major axis. So A, if you write here, is 3. B is 2. So along the x-axis, I'm going to go 3 to the right, 3 to the left. In the y direction or y-axis, minor axis, I'm going to be going 2 above, 2 below. And there's our ellipse that we have graphed. We want to find the foci as well. So to find foci, we need c squared equals a squared minus b squared. C squared equals bigger number minus a smaller number. C is equal to plus minus square root of 5. So square root of 5 is around 2 point something. So I'm going to mark F1 here, F2 here. Coordinates of foci, 1 would be root 5, 0, and F2 would be negative root 5, 0. See another example. Find the center vertices of major axes, vertices of minor axes, and foci using the following equation. Now, this equation is not given in very nice shape and form because I don't have, I will have to complete the square to put it in the nice shape and form. So let's go ahead and get the x terms together, close to each other, and y terms close to each other, and move the constant to the other side. So we haven't done anything to the equation yet. We kind of got x terms, group them together, y terms we group together, and move the constant to the other side because I'm gonna try to complete the square to put it in the nice shape and form to be able to graph it. Now pull out 16 from here. X squared plus 16 times 6 is 96. And pull out a 4 from here. Y squared minus 2y equals negative 84. Now I'm going to be completing the square. There was an x here as well, 6x. What number should be added over here to complete the square? Half of 6 squared, which is 3 squared. So I'm going to be adding a 3 squared here. Now, if I add 3 squared to the left-hand side, I have to do the same thing to the right-hand side as well. But if you be careful here and you notice that I'm not adding 3 squared, I'm actually adding 16 times 9 because we have already factored a 16 out in the parentheses. So 16 times 9 is 144. I must add it to both sides. For the y parentheses, I would be adding 1 squared, which is half of 2 squared, 1 squared, and I'm technically not adding just 1, I'm adding a 4. So I must add a 4 on the right-hand side as well. 16 times x plus 3 squared plus 4 times y minus 1 squared equals, on the other side, we'll have 64. Now to get a 1 on the right-hand side, let's divide everything with a 64 and simplify it. X plus 3 squared over 4 plus y minus 1 squared over 16, because we can cancel between the fractions here, equal to 1. So this is the parabola that this is the ellipse that I will be graphing here. So this ellipse has a bigger number under y, and the center is shifted as well. So we got to be careful now. The center is shifted. So center is going to be, for this ellipse, center is negative 3 and 1. X is negative 3, y is 1. So this is where the center is. I'm going to mark it negative 3, 1. And the bigger number is under y, so y side or something along a vertical axis will be my vertical line will be my major axis in this case. So along the line of major axis, I need to go 4 up, 4 down, because this is 4 squared. So go 1, 2, 3, 4 up, 1, 2, 3, 4 down. And along the minor axis, I will be going 2 to the left, 2 to the right. So 2 left and 2 right. And that's our ellipse graph. Now make sure we label the coordinates between negative 3, 1. If we went 4 above, I was at negative 3, 5. And if I go 4 below, I'm at negative 3. If I go 4 below, I'm at negative 3, negative 3. And going to the left and right, the co-vertices Remember, the y coordinate does not change when we move left and right, but the x coordinate will change. From -3, if I go 2 to the right, I'm at -2. If I go 2 to the left, I'm at -5. And there's my ellipse here graphed. To find coordinates of foci, we need c square is equal to a square minus b square, and they will be plotted along the major axis, and we will have to consider the center as well. In this case, again, when the center is not 0, 0. So 16 minus 4, that's 12. C square is 12. This gives me C is plus minus square root of 12. So foci would be, coordinates of foci will be, they are along the center line. So we'll have coordinates of foci as -3 and -1 minus 2 root 3, because this is square root of 12 can be written as 2 root 3, -3, -1 plus 2 root 3. So our foci would be somewhere along the major axis, F1, F2. All right, see, here's a graph that we just did. There's a graph of that equation. We wrote this in the standard form and we went ahead and graphed it. And there's a decimal points for the foci if you wanted the decimal equivalents. Next, write the equation of ellipse given foci plus minus 4 and vertices plus minus 5, 0. So I'm given the foci and vertices. It's helpful to draw these points to get some estimate or idea how the equation should look like. Foci are at 4, 0, -4, 0, F1, F2, and the vertices are at 5, 0, -5, 0. So I can clearly see that x-axis is the major axis here. So x-axis is going to have a bigger number. X-axis is going to have, so it does not look like equidistant here. F1, F2, and here's my first vertex 5, 0 and -5, 0. Right, so x-axis is the major axis, x squared plus y squared equal to 1. And along x-axis, I'm going 5 units to the left and 5 units to the right for the center. So I would be at x squared over 25 plus y squared over b equal to 1. That's my equation in this case, but I need to find the b. We can go ahead and use c squared equals a squared minus b squared. So foci is the coordinates of foci, or the c is 4 in this case. So we can see 4 squared is equal to a squared minus b squared. 4 squared equals 5 squared minus b squared. That would leave us with b squared is equal to 9. So we can plug this back into the equation. X squared over 25 plus y squared over 9 equals 1 is the equation for this given ellipse. Let's see another example of writing equation of the ellipse. We're given the foci and we're given the vertices. It's very important to go ahead and graph them first to see what is your major axis and what's the minor axis. So foci are plus minus 10, and that's not possible. It's probably square root of 10 because foci have to be inside the inside the ellipse. So I'm gonna say this is my vertices 1, which is 0, 7. This is another vertex, 0, -7, another vertex. And there's my foci, which is square root of 0, square root of 10 positive, 0, comma, negative root 10. Square root of 10 is like 3 point something, around 3.1, 3.2, because it's between 9 and 16. Those are the two perfect squares. All right, so let's go ahead and think about here. Y is going to have the bigger number in the denominator, and y squared is going to have 49 in the denominator. So x squared over b squared plus y squared over 49 equal to 1. The center is 0, 0. As you can see, that's exactly in the middle of my vertices. Whatever number is exactly in the middle of my vertices, we can find midpoint of the two vertices. That's going to give us the center. Now to find the b, we can use c squared is equal to a squared minus b squared. C is square root of 10, and a is a bigger number, 49 minus b squared. 10 is equal to 49 minus b squared. So b squared is equal to 39. B, we actually don't need the b, we need b squared. So this equation for this ellipse is going to be x squared over 39. X squared over 39 plus y squared over 49 equal to 1. All right, that was all for ellipses.